All right, ladies and gentlemen, we're going to take a look today at mineral formation. How are minerals formed? Where do they come from? And then we're going to take a quick look at how minerals are grouped or categorized. So we're going to start with taking a look at three different ways that minerals form. One is from magma. So minerals form from magma. Magma, of course, is melted rock that is inside the earth. And so some minerals are formed when that liquid rock, that melted rock, cools and hardens. Now, magma that cools and hardens underneath the earth's surface, um, it does so very slowly. So it happens very slowly because it's still very hot in there. So it's not till it gets near the crust. Remember, down if it's down near the inner core, it's not going to cool and harden there. But as it gets closer to the crust, um, it sometimes is able to cool and harden. It happens very slowly, and because of that, the crystals grow slowly and they become quite large. On the other hand, we can also have minerals that form from magma that has come above the Earth's surface, which is now known as lava once it has reached the surface of the Earth. And the lava, because it is above the surface of the Earth, cools much faster than the magma, and therefore the crystals are really small. You can't really see them very well. If you looked at a if you looked at a mineral that was formed from lava, you might not even realize there were crystals in there because they are so small. Keeping in mind, lava is still really hot. The picture that we have here, we're talking about lava that's hundreds of degrees, but it is in the process of cooling and hardening. Minerals can also form from solutions, and basically, a solution is when solids are kind of suspended in a liquid. So, think salt water. We've got salt, a solid that is dissolved and uh, that is dissolved in water and is suspended in that water. And so, as the water evaporates from a solution, it leaves behind those solids or those mineral particles in this case. Oftentimes, what happens is water runs through rock. The water kind of washes some of the stuff in the rocks, the minerals in the rocks, into the water. Then, as that water evaporates, it leaves behind the minerals. Water can only hold a certain amount of dissolved particles, and when there are too many of the particles in the water, then they start to come together and they start to crystallize and form solids. The picture that we have here is an example of a mineral formation formed from a solution, a saltwater solution in this case. Minerals can also form because of pressure. So, in fact, minerals can even change from one type of mineral to another because of pressure. So, minerals change form, they can become different materials altogether as pressure and temperature as well change. And so, certain minerals can go through different kinds of phases depending how much pressure has been applied to them or how much the temperature has increased. So, for instance, we've got here what's called a phase diagram for a mineral. The mineral is Al, which is aluminum, Si, which is um, is silicon. Thank you. Just forgot. Aluminum, silicon, and oxygen. So Al2SiO5. And this particular mineral, depending on how much pressure it has endured and what temperatures it has gone through, might be known as kyanite or andalusite or sillimanite. So it can be any of these things here, depending on what it has experienced for pressure and temperature. All right, now we're going to take a quick look at mineral groups. We can basically divide all minerals into two groups. They're known as the silicates and the non-silicates. So silicates have silica in them, non-silicates do not. As it happens, silicates are the largest group. So there are a lot more silicates than there are non-silicates. these minerals are made up of what is called a silica tetrahedron, which basically means that you have the atoms that make up these minerals, these silicates. There's a silicon atom at the very center of this shape, and then it's surrounded by oxygen atoms. And the way the oxygen atoms arrange themselves around the silicon atom, it forms kind of a pyramid shape, which is also known as a tetrahedron. All right. So some examples of silicates would be things like quartz. We've got a piece of pink rose quartz over here, although quartz comes in all kinds of different colors. And there's also a piece of feldspar down here, which is also a silicate. And again, there are a lot of different silicates. These are just two examples. Now, the non-silicates are the other category. It is a smaller group, and yet we divide it into 7 smaller groups because even though it's a small group, there's a lot of like different types of minerals here that some of which are not very closely related, with the exception of the fact that they don't have silicon in them. So we divide those into 7 smaller groups. One of those groups is the native elements. So these minerals are made up of just one kind of atom. So there are not a lot of this type of, that shouldn't say element, that should say mineral there. There are very few of this type of mineral. My apologies for the typo. Um, and some examples: gold. Gold is made of just gold atoms. Silver, made of just silver atoms. Sulfur, made of just sulfur atoms. Diamond, not made of diamond atoms. There is no such thing, really. Diamond is made of just carbon atoms. All right, so it's made of just one element from the periodic table. Another type of non-silicate is carbonates. These are formed when a carbon atom bonds with 3 oxygen atoms. So one example of that is CaO3. And one example of this type of mineral would be a calcite, which you can see a picture of to the left there. We also have halides. Halides form when salt water evaporates. Um, so you can imagine that for the most part, halides are pretty salty because essentially what's left behind is salt. Sometimes there are some other things left behind as well that mix in there and help to make the crystals. But halite and fluorite are examples of halides. The non-silicates also have a group called oxides. And this is when either one or two metal elements combine with oxygen, atoms. So magnetite is one example of this. Magnetite is pretty cool because it is magnetic. And you can see a picture of magnetite over to the left. Oops. Try again. Phosphates are another non-silicate. They're a lot like silicates, except for, well, the silicate isn't in, the silicon isn't in there, but they do have a similar structure with that tetrahedron type structure. They're not very common. One example, though, is apatite, which is a pretty important mineral because it is actually the main component of your bones. So we think a lot about calcium when it comes to bones, but actually there's more apatite in your bones than there is calcium, which is pretty, or at least they're pretty close in there. So apatite's pretty important when it comes to you. Sulfates is another non-silicate. They are made up when not silver, but sulfur. When sulfur chemically binds with oxygen. And they can also form when salt water evaporates. So if there is sulfur and oxygen in the water that evaporates, then sulfates can form there. One really important example of sulfates is gypsum. Gypsum is used a lot in construction and wallboard and things of that sort. Sulfides sounds a lot like sulfates, not the same thing. Sulfides, they form when metals combine with sulfur. All right, so sulfur's involved again, but you'll see back in the sulfates, sulfur was binding with oxygen. Here, the sulfur's binding with metals. And one example would be pyrite, which many of you might know of as fool's gold. It looks a lot like gold, but its structure is different. Its atomic structure, the types of crystals that it forms, is different. So, pyrite is known as fool's gold. You know, we put these minerals into categories in order to be able to talk about them, to be able to relate their similarities and their differences. Again, we have 8 groups altogether. We have 2 main groups of silicates and non-silicates, and then we break those non-silicates down into 7 categories. There you have it, ladies and gentlemen. Have a great day.